Okay, so this is the second example I'm going to give you. I just want to give you one more example where I compare these two, a rational expression and a rational equation. I think it works best for you guys. You get it the best if I can show you two that look exactly the same virtually, except one, one is an equation, one is expression, and to see exactly what we do the same with them and exactly what we do different with them. So look at this one. Take a second, tell me if it's an expression or an equation, or tell you, I guess. Okay, now look at this one. Is this an expression or an equation? Okay. So I hope with this one you said it was an expression because it does not have an equal sign. And this one, I hope you said it was an equation because it does have an equal sign. Remember, an expression, we are going to simplify, and we use an LCD, and it means we keep the denominator. Go away. We simplify. Okay, and an equation, we solve. We use an LCM to get rid of the denominator. And our answer always has to be x equals something, or in this case, b equals something, whatever letter you're solving for. So let's get started, okay? So on the expression, first thing we do is see about factoring everything in the denominator. Well, this denominator, I can factor out a 2. That leaves me with b minus 6. There's nothing I can factor in this denominator, nothing I can factor in this denominator. In an expression, the very first step is to factor out everything in the denominator. So I can factor out a 2, and I cannot factor this denominator or this one. Let's go back to the expression. Okay, so now the next thing I need to do is build my LCD. For an expression, remember, it's always an LCD, meaning we're going to keep the denominator. So remember, this is like building a building. This is our LCD or our LCM building. And I need to start with a really good foundation. So what I do is I take everything from the first one, no matter what it is or how much it is, or anything like that, whatever it is. Then I ignore that one and the third one, and I just look at the middle one and I say, okay, in my building, this says I have to have at least one quantity b minus 6. Well, I already have that in my building, so I don't need to get it again. So then I ignore the first two and I look at the third one, and this tells me in my building I have to have at least one standalone 2. That means a 2 all by itself. Well, I have that right here. So I'm good to go with my LCD. Now let's look at how we do this in an equation. Well, guess what? We're going to build our LCM. It's an LCM building, so I need to start with a foundation. So I'm going to use the first one exactly like it is. Then I'm going to ignore the first one and the third one. I'm going to look at this one, the second one here. This tells me in my building I need to have one quantity b minus 6. Well, I already have that, so I don't need to include it. Remember, say include, not add. Include or multiply, either way, because these things have to be multiplied together. If you say add, I guarantee you're going to put a plus sign and then you'll really get messed up. Okay, now I ignore the first two. Look at the third one here. It says in my building I have to have at least one standalone 2, so a 2 all by itself. Well, I have that, so I've got my LCM. Now, here before I go on, I need to figure out what b cannot be. So 2 doesn't have a b with it, so I don't need to worry about it. I just need to do b minus 6 equals 0, and I get b equals 6. So up here I'm going to put b cannot equal 6. Other than that, I don't need to worry about it until the very end. But just think about this. If we come out with b equals 6 and we put 6 in for this b, 6 minus 6 equals 0. And we cannot have 0 in the denominator. It makes it undefined. So no matter what, by the time we're done, if we end up with b equals 6, we can't have that, and we need to know that. But for right now, I'm not going to worry about it anymore until I get to the end. So now I'm going to go back to the expression, and this is how we do this now. Okay, first I'm going to write the first term exactly like it is with the denominator in factored form, and then I'm going to look at it and say, what do I need to multiply with this to get all of our LCD? Well, technically 1. You do not need to write this. I would say nothing really, okay? Then I'm going to write my second term exactly like it is, and with the denominator like that. And then I'm going to look at it and say, what do I need to multiply with this denominator to get all of this LCD? Well, I need to multiply 2. If I do that with the denominator, in the denominator, I need to do it in the numerator as well. And then I go ahead and write my next term, okay? And then I look at this and I say, what do I need to multiply with this 2 to get everything in my LCD? Well, I would need to multiply b minus 6. But if I do that in my denominator, I need to do it in my numerator. Okay? Now let's go see how we do this in our equation. Okay? So this is where we do things just a little bit differently. And again, guys, write it out like this. I guarantee if you get used to doing this, even though it seems like such a huge undertaking and waste of time, you actually will save yourself lots of time and headache and usually get the answer right. So the first thing I'm going to do is write my LCM, and then I multiply it, hence the M for multiply, with the first term. Again, keep your denominator in factored form. Okay, then I put my sign. Then I go ahead and write my LCM again. And then I multiply it with the second term. And then I put my equal sign. If there were minus on the other side here, the b minus or b over 2, I would put my minus here and then my LCM. But I don't have a minus, so I'm just going to put my LCM. And again, you guys don't need to do different colors. I'm just doing this so you can see what's the same and what's different. And then I multiply it times the last term. Okay? Now let's go back to our expression and see what we do next. Well, now I've got the same denominator in everybody. So now I can just write that denominator. And then I'm just going to do what happens in the numerator. So 1 times b minus 2 is b minus 2. Now be very careful because I've got this 2 here and this negative. So I'm going to write it like this to begin with. Oh, that's a b, not a 6. I hope you guys caught me on that. Okay, so b plus 2. So you see, all I did was take the 2 here along with the negative, put it in front. Next time I'm going to distribute that so that I don't screw anything up. And this is negative b I want to take, so that makes it negative b squared because I'm distributing it into both of these. So negative b squared, negative times a negative is a positive, and that's 6b. Okay? I'm going to go ahead and finish this up by distributing that, including the negative. So b minus 2 minus 2b, because I'm distributing this into the b plus 2. And I get negative times a positive is a negative. 2 times 2 is 4. And then I've got b squared plus 6b all over my denominator. Now I'm just going to go ahead and combine like terms here. So I'm going to put the negative b squared out in the front. And then I've got this b and negative 2b and positive 6b. So b minus 2b is going to give me negative b, plus 6b is going to give me plus 5b. I think I did that right. That's 4 plus 1 is 5. So these are gone. And then I'm left with negative 2 and negative 4. That's an addition problem whose signs are the same. So I add the numbers, keep the sign. Okay, put my denominator. Okay, just to be on the safe side, I'm going to factor out the negative. So that changes the sign of everything in between. And then I'm going to factor. So that would be a double bubble because this is not a perfect square trinomial. This is a trinomial and that has a 1 coefficient. So a b and a b. And 6 is 1 times 6, 2 times 5, 2 times 3. I think it should be this, minus 2, minus 3. When I add those two together, I get negative 5. Negative times a negative is a positive. And so minus 2 and minus 3 and 2b minus 6. Nothing I can cross cancel, so that actually means I can leave my answer this way. You could leave it this way too, but that's not usually how we would do it. I would leave it either this way or this way after you have factored it completely. Either way is fine, but just remember that the numerator can be left in factored form. I'll put, because this is the way it is, left in multiplied form. Or in factored form. But the denominator must always be in factored form. Okay? Now let's go back to the equation, and I might have to finish this one on the next video because I'm out of time. So I will be back in the next video.